With respect to a fixed origin O, the lines L1 and L2 are given by these equations here, where lambda mu are scalar parameters. Show that L1 and L2 meet, and find the position vector of their point of intersection. Find, to the nearest 0.1 degree, the acute angle between L1 and L2. So let's have a look at this then. We're just going to do parts A and B in this slot here. So first of all, these two lines here meet. I've written them in vector form when the x, y and z components are all identical. So let's have a look at the x component here then. 6 minus lambda, that needs to equal the x component here, minus 5 plus 2 mu. The y component, which is minus 3 plus 2 lambda, needs to equal the y component of this line, 15 minus 3 mu. 15 minus 3 mu, that's it there. Now we've got two equations in two unknowns straight away, so we can solve and see what we get for lambda mu here, can't we? So let's double this one to get minus 2 lambda here. So this tells us now then that 12 minus double this is 2 lambda will equal double this then, minus 10 plus 4 mu. Now if we add, this is number 3, now we can label it. If we add 2 and 3 together, now we're doing that because the lambdas will cancel. 12 minus 3 is 9, is equal to, and on the other side 15 minus 10 is 5. Minus 3 mu plus 4 mu is just a mu. So straight away that tells us what mu needs to equal then if the lines are to intersect. 9 minus 5 is 4. So now let's get lambda. 6 minus lambda then from here. Put mu is 4 in here. You get 8 minus 5 is 3. So that tells us then, move the lambda over this side and read from right to left. Move the 3 across here. 6 minus 3 is 3. So lambda equals 3 and mu equals 4. Now let's check the z component also intersects. So the k vector part then, what have we got? Minus 2 plus 3 lambda needs to equal 3 plus mu. So let's put the values in and see if they do intersect. So 4 for mu, 3 plus 4 equals 7. And here minus 2 plus 3 mu, 3 lambda, 9 minus 2 is 7. So yes, so lines intersect. Okay, great. And at the point, where do they intersect? Well, they intersect where lambda was 3. Here's the x value here we can write it as a column vector, can't we? Lambda is 3. 6 minus 3 is 3. Then the y component, which was this equation here, wasn't it? So lambda was 3 again. 6 minus 3 is 3. And then finally the z component was 7. We already wrote it down just there for the check. 3, 3, 7 is where the lines intersect then. So that's the point A. Okay, so that's part A done. Find to the nearest 0.1 degree the acute angle between the lines L1 and L2. So let's do a little picture then for part B. Here's L1, suppose, and here's L2. Oh, L1. And here's L2. They meet at the point A, don't they? We can call this angle theta, and then we can use the dot product rule, can't we? So these are directional vectors from the equations of the lines. So we can work that out then. So let's label that B1 and this B2. So B1 as a vector dot B2 will equal the modulus B1 times the modulus B2, cosine of the angle between them. So that tells us what cosine is then. We can now rearrange. It's just the dot product of B1 dot B2 divided by the moduli of both of those parts, B1, B2. Like so. Now B1 is equal to, now we just need the directional vector from the line 1, minus I plus 2j plus 3k. Minus I plus 2j plus 3k. So we've got that, and then we also need B2, which is 2 minus 3, 1. So B2 is 2i minus 3j plus k. So there's our B2. I'm just going to double check that. 2 minus 3, 1. Yeah, that's fine. So there's our values then. So that tells us then, so cosine theta is equal to b1 dot b2, this dot this, minus 1 times 2 is minus 2. 2 times minus 3 is minus 6. I'm doing the dot product here. And 3 times 1 is plus 3 over the square root of, now modulus b1 is 1 squared plus 2 squared plus 3 squared. Minus 1 squared, but it's still 1 squared, isn't it? And then the modulus of b2, which will be 2 squared plus minus 3 squared plus 1 squared, so it's the same. So that's what we've got then for our cosine, which equals minus 8 plus 3 is minus 5 over 9 and 4. 9 and 1 is 10, and so we've got root 14 times root 14 is 14. So theta then is equal to shift cosine of minus 5 over 14, which equals, let's type that in the calculator then. So move our calculator somewhere convenient. Here, say. So shift cos, make sure in radians, in degrees mode. So we want to be in degrees mode, and then we do shift cos negative 5 divided by 14, close bracket, equals 110.925. So let's write it down nice and accurately. 110.925 10.92. I'm going to write 48 dot dot dot, because that's what it was. So then that will tell it, that's an obtuse angle, isn't it? And it asks for an acute angle between the lines. So I'm going to label that theta dash now, and this must be the obtuse angle theta, mustn't it, that we've worked out here. So we can now write theta dash is equal to the nearest 0.1. So let's write the angle, which is going to be 69.075. So equals 69.1 degree to nearest 0.1 degree.